Evaluate integration of x power 8 by 1 plus x power 18 into dx. Here we have to apply the substitution method, means after the differentiation we should get the term in the question. If you take x power 8 as t, means the differentiation will give you 8 x power 7, no use. If you take x power 18 as t, means the differentiation will give us 18 will come in front and reduce to 1. So 18 x to the power of 17. It is also no use. So in this situation we have to take half of the highest degree. So the given one we have to take I, then t is equals to, we have to take as x to the power of half of the term. So we have to take x power 9. So now for this we have to do differentiating with respect to x. So t differentiation dt by dx, and x power 9 means power will come in front and it will reduce to one term. So it will be 9 x to the power of 8. Next, cross multiplication dt by 9 x power 8 is equals to dx. Next we have to write I as integration x power 8 by 1 plus 18 we can write as 9 square, 9 into 2, x power 9 into 2, like that. So x power 8 is as it is, 1 plus x power 9 as we have taken t and outside square as it is, dx in the place, dt by 9 x to the power of 8 we got. So x to the power of 8, x to the power of 8 cancel, and 1 by 9 is constant in front, 1 by 1 plus t square dt. So it is looking like the formula tan inverse x. So x in the place t na, so tan inverse t plus c. But what we have taken t as tan inverse x power 9 plus c is the answer. Evaluate integration 1 by x plus 1 into x plus 2 into dx. So here we have to follow the partial fraction concept, max 2a concept. So first we have to take 1 by x plus 1 into x plus 2 as partially fraction. So denominator one part we have to write 1 x plus 1, another is x plus 2, and numerator we have to write a, b, because here x degree 1 only 1 letter a, here also x degree 1 only 1 letter b. Next, LCM. X plus 1 into x plus 2, and this will comes to a into x plus 2, and here b into x plus 1. So here denominator cancel, in the LHS RHS only what left are 1 is equals to a times of x plus 2, b times of x plus 1. Take this as star equation, this one equation. Let x is equals to, once you have to take x value minus 1. Why? Because if you take minus 1 it will become 0. So once you have to take x value minus 1. So what will be? 1 is equals to a into minus 1 plus 2 and plus b into 0. Minus 1 plus 1 0. So this will be what? 1 is equals to a. A value is 1. Next we have to take x is equals to minus 2. Then only it will be 0 na? So once we have to take x value as minus 2. So what will be in this first equation? 1 is equals to a into minus 2 plus 2 will cancel, it will be simply 0, plus b into minus 2 plus 1. So will give you minus 1. So 1 is equals to minus 1 into b is minus b. Therefore b value is how much? Minus 1. Those value we have to substitute in the star equation. So this star equation will becomes 1 by x plus 1 into x plus 2 is equals to, a value we got as 1, so it is 1 by x plus 1, b value we got as minus 1, so it is minus 1 by x plus 2. Now apply the integration on both sides. It is 1 by x plus 1 into x plus 2 into dx is equals to integration 1 by 1 plus x dx we can write now minus 1 by I can write as 2 plus x dx. So integration 1 by x it is looking like. So answer log mod x. So mod not compulsory. So this is log mod 1 plus x and minus, and it is also looking like 1 by x integration log of 2 plus x plus c we can write as log c also. And one more thing, it is looking like log a minus log b formula. The formula is log of a by b. So here 1 plus x by 2 plus x plus c is as it is. Integration of sine of tan inverse x by 1 plus x square into dx. So here, observe here tan inverse x differentiation 1 by 1 plus x square. So we have to take substitution method. T is equals to tan inverse x from the question I. So differentiating with respect to x. So t differentiation dt by dx. Tan inverse x differentiation 1 by 1 plus x square. So cross multiplication. So 1 plus x square into dt is equals to dx. So substitute in our question I. So here I is equals to integration sine of tan inverse x in the place t by 1 plus x square is as it is, dx in the place 1 plus x square into dt. So 1 plus x square gets cancelled. Only the integration sin t dt. Sine integration is minus cos t plus c. So minus cos of t in the place we have taken as tan inverse x plus c is the answer. Integration of 1 plus cos square x by 1 minus cos 2x. Here angle multiplication 2. So denominator looking like one formula, trigonometry 1 minus cos theta. The formula is 2 sin square theta by 2. So how much angle is there in that half? Theta means theta by 2. So here 2x means 2x in the half, simply x. So we can write as denominator as 2 sin square only x dx. So this 2 I am writing in front, and numerator 1 plus cos square x by sin square x into dx. Then integration separate division 1 by sin square x plus cos square x by sin square x. We can directly write the step without this directly also, but students gets confusion. So 1 by 2 as it is. 1 by sin square is cosecant square x, and cos by sin is cot square x dx. So here cosecant square formula is there, but cot square formula not there. So we have to use the trigonometry identity. The formula is what? Cosecant square theta minus cot square theta is equals to 1 na. Cosecant square theta minus cot square theta is equals to 1. So from this cot square is equals to what? Cosecant square minus 1 na. So here 1 by 2 as it is, integration cosecant square x is as it is. Instead of cot square we can write as cosecant square x minus 1 into dx. So integration of cosecant square plus cosecant square 2 cosecant square x minus 1 into dx. So 1 by 2 as it is, 2 as it is, cosecant square integration is minus cot x, and 1 integration is x dx, x plus c. So the answer is, we can multiply with the 2 table. So minus 2 cot x and division by 2 minus x by 2 plus c. 2 gets cancelled, minus cot x minus x by 2 plus c. integration under root of 1 minus cos 2x into dx. Again here looking like the formula 1 minus cos theta. Formula 2 sin square theta by 2. So 2x in the half, simply x. Integration under root of formula application 2 sin square x dx. So root 2 as it is and square root cancel for sin. So root 2 constant we have to write in front. So integration of what left over? Only sin x into dx. Sin integration minus cos x. So minus I am writing in front, minus cos x plus c. Integration of x e power x by x plus 1 whole square. So to get the formula here, numerator denominator should be same. So for x 1 is missing now. So we have to add and subtract with 1 to x. So e power x by x plus 1 whole square into dx. I am writing e power x2 in front. And next I am writing separate division x plus 1 with the denominator and minus 1 separate into dx as it is. So observe here 1 x plus 1 x plus 1 gets cancelled. Integration e power x into 1 by 1 plus x we can write. And next minus I am writing plus of minus 1 by 1 plus x whole square into dx. Now it is looking like e power x into f plus f dash. It is f, it is f dash. Why? Because 1 by x differentiation is minus 1 by x square. So the formula is integration e power x into f of x plus f dash of x into dx. Formula e power x into f of x plus c. So here the answer is e power x into f is 1 by 1 plus x plus c is constant.